think it's recording. Hi, everybody. Hope you're all doing well. Uh, Thank you for going through the lessons from Ms. Wu. I felt guilty that I wasn't recording my own lesson there. I started to do it, and then I looked at hers, and it was better. And the other thing I thought is, you guys are going to hear my voice a lot in the coming weeks. You could take a break from it. So, thank you for taking care of that on Edpuzzle. I'll make sure that gets entered in as a formative if I haven't already done so. Today, we're going to do some more vector review. This is our last day of asynchronous learning prior to when I finally get to see you guys on Thursday and Friday. So we're going to work through sort of some vector review together. Now, I had this sheet printed up, but because I haven't seen you, you can either print it or you can do your work on a separate sheet of paper. It's not that intensive. You guys can handle it. I'd like to go through some really basic vector review and then end up with a problem that takes an entire page. I'm hoping 20 minutes. We'll see where it goes. I hope you guys are doing well. I am psyched to finally get to see you later on this week. So without further ado, if you haven't already printed out the PDF that is there, take a moment and do that. If you don't have a printer, push pause, open up that PDF so you can copy down the problem. So you can probably leave the words out. It's okay. So here's what we're going to do. Work through a series of fairly simple questions. Review a vector addition. Now, I know that you know that vector addition is really the key for adding values that are not just on the number line. Because vectors have, yeah, that's right, direction and magnitude. We all learned that from that movie. What was that movie again? That's right, good. Now, what I'd like to do is just sort of work through some quick examples. So if you could, adding vectors that are in the same direction. This is pretty similar to just adding two numbers. However, let's just go through the process. So if I take vector A and B and I add them together, now the length of these vectors represents the magnitude of the vector. So if I have vector A here, and I need to add that to vector B, I'm going to add them by what's called tip to tail, where I literally take the tip of one vector and I put it on the tail of another. Then what I have is from the start to the finish. I'm pretty sure this is just like adding 2 plus 3. You just add them together. Now, the resulting vector would be from the start to the finish, and it does have a direction, so I show that as an arrow, and I'm going to call that C. That C is known as the resultant. And while I know that just sounds like a made-up word, it's not. It's the result of adding two vectors together. Moving on. Now, adding vectors that are in opposite directions. Honestly, this is just like adding, say, a negative number. Or we could even call it vector subtraction. Because that's really what we're doing, vector subtraction. Now, if we go to our tip to tail method, we're going to have vector A. I'm going to try to draw that the same length as in the problem. And vector B is going back. So the resultant would just go from the start to the finish, and my resulting vector would be C. So I could write that as that is equal to C. It doesn't have to be anchored at a starting point. It's really just a magnitude and a direction. Good. Those were too easy. Don't be insulted. I know you're smart. Now, adding vectors that are at right angles to each other. This is something we did repeatedly. Think about all the work we did with projectile motion, right? We were always looking at a velocity in the X and a velocity in the Y. We looked at force problems like this. We did a lot of work with vectors, and we're going to when we talk about electrical forces and electrical fields coming up. So when we add two vectors that are at right angles to each other, I'm going back to tip-to-tail method. A plus B. And then I start at the start and end at the end. It's going to go from here to there. Now that vector C, the arrow gives the direction that it's pointing, but there's another way that I can give the direction, and that is if I define what that angle theta is. Okay? Now, mathematically, if I look at this, there's two different things I could do. I can use c squared equals a squared plus b squared. Come on, everyone loves that, right? Pythagorean theorem. And then to find theta, since b and a were given to me, I could use one of my trig functions, sine, cosine, or tangent. So I know opposite and adjacent, so I can say the tangent of theta equals b over a. And because you guys have been on summer vacation for quite some time now, I'm just going to remind you that we would take the inverse sine of that value in order to get to theta. Yeah? I know you know that. Good. Make sure your calculator is in degrees in this section. That's going to be an issue for many of you in calc or pre-calc. Just got to go back and forth. Now, those have all been building to this last one, because it's really the last one that is more, it's the interesting one. The other ones are too easy. So here, if I want to add vectors that are in any direction, I still follow the same process. I'm still going to go from beginning to end. So I can go in any order, but I might as well start with A, followed by B. I'm going to try to draw these to scale, followed by C. Tip to tail, tip to tail, tip to tail. Okay? Seem all right? So now, to come up with my resultant, I'm going to go from the start to the finish, and that's going to be D with an angle theta. Now I'm recording this at school, and the bell just rang, so I'm going to push pause for a moment. Maybe, maybe not. You guys can't tell me you missed that. The sad, sad music that we play between changing classes. I don't understand why it's so depressing. Just because it's classical doesn't mean it's relaxing. It can often just be depressing. That's what classical music can be. Enough. So, how the heck do I do this? Well, you know what you end up having to do is you have to break these guys up into components. So, my first step when I look at this would be to take the A vector and break it up into A in the X direction and A in the Y direction. I can do the same with B. Go ahead, do it. Do it. And then C, well, C is just in the X direction. So my first step, step number one, would be to break up vectors into X and Y components. Now we can do that, again, using our right angle trig, sine, cosine, tangent. Okay. Number two, we are going to sum up all of the vectors in the X direction and sum up all of the vectors in the Y direction. Now in the X direction, can I sum anything up if I don't know which direction is positive? I don't think I can. I'm going to make up and write positive. Thank you for pointing that out, guys. So if I'm going to add these vectors in the x and y, let's take a look. Now, vector A, x is pointing to the left. So that's actually going to be a negative component. Bx is in the positive direction, and C is just to the right, so that's positive. In the y direction, I'm going to have plus AY plus BY plus 0. Yeah. Now, this is review, but it's important. So I want to draw a picture. Okay. What we're really looking at here, if we go from start to finish, ready, is that I have AX to the left, followed by BX to the right, followed by C. So if I were to look at my components, the X component would go from the start to the end. Okay, and I'm gonna redraw that right over here. Whoop. And then in the Y direction, I'm going to have AY plus BY, and there is no C. So that just gives me the the Y component. Now those two vectors that I have are the components of the resultant. So my third step is to redraw the components of the resultant. And then number 4, solve it up. When I have that, I apologize for my handwriting. I haven't been out of practice here. If I were to add those tip to tail, I would have X and Y. And if I draw in the resultant from the beginning to the end, I'll call that Z. And an angle theta. All right, I'm going to stop there for now. We're going to do a tricky problem that ties this all together in just a moment. I want you to, we'll go on to the soothing music. All right, we're back. So far we've gone over sort of the 4 basic steps that one would follow if you're doing basic vector addition. If you're just adding 2 vectors in the same direction, subtracting 2 vectors, what happens if they're at right angles? And if they're at different angles, we still follow the same process. We try to get them all broken down into just their X and Y components. So let's piece it all together. I need you to take out, or maybe flip the paper over that you're working on, and we're going to try this problem together. Now, I want you, as you're drawing these, to draw the vectors to scale as best you can. So I want you to push pause and draw out those vectors. Ready? Pause. Good. You're back. Here we go. So my first step is going to be to add these vectors tip to tail. I do this because it gives me a sense of where my resultant is going to lie. So I'm going to start with, I don't know, maybe the easiest. I'm going to start with 8 newtons to the right. Newtons per coulomb, excuse me, that's a unit we're going to be using for electric fields soon enough. I've got 6 up. Now I can add these in any order. I have 10 at 53 degrees. And that's going to be 53 degrees as a reference angle, not 53 degrees in the coordinate plane. And lastly, 5 at 37 degrees as my reference angle. Okay, how you feeling? Now, some of you are saying, did I have to add it in that order? Of course not. You asked that question because you know the answer. Good for you. If I add the numbers 10 plus 6 plus 8 plus 5, what do you get? Oh, shoot, I should have figured that out ahead of time. 29. If I add 5 plus 6 plus 8 plus 10, what do I get? Yeah, it's still 29. I can add them in any order. The same is true for vectors. Okay? So my resultant is going to be something like that. The angle that we're going to define it as, we'll get to that in a bit. So, because these vectors are at an angle, I need to break them up into components. So my first step, number 1, is to break the vectors up into components. Nice, some of you are already doing that. Good for you guys. Good for you. So 10 with a reference angle of 53 degrees. Now, got our calculators out. In order to find the x component, okay, our x component and our y component, see, this is tricky. What are you going to label those? I'm just going to label those x.
So after reviewing my work, I thought that I could just speed this up. Now, if you're not able to follow my work clearly, push stop at a certain point. Realize all I'm doing is taking the sine and cosine and solving it up. That's it. You got this.
So let's back away from the problem for a second. The whole idea is to take those 4 vectors and add them together. Now, we can handle that by just breaking them up into components and doing things we've done since the second week of physics last year. So my next step would be to add up all the vectors, components. So I want to find the sum of, now for a symbol here, Newtons per Coulomb is an electric field unit. And I believe if this was literature, which it's clearly not, this would be considered foreshadowing. Electric field is measured in newtons per coulomb, and the symbol for the electric field is capital E. Get it? Electric field. So I'm going to say the sum of the electric field in the x direction is equal to, now let's add them up. My green 10 newtons is to the left, so minus 6. My red is straight up, so that's 0. My blue is to the right, so that's positive. And my black vector is to the left, so that's going to be negative. So minus 6 plus 8 minus 4 is going to give me negative 2 newtons per coulomb. I did it! I came up with these signs. How did I come up with those? What was I in reference to? That's right, my positive arrow. 2 points for everybody that yelled that out at their computer. Sorry. Now, the sum of the electric fields in the y direction, I can solve for pretty easily. It's going to be the component right here of that green vector, which is 8 newtons per coulomb up. So plus 8 plus the 6. Now that's the red 6 that we're talking about right here. Plus 0. And then finally, this black vector in the downward direction was negative 3. 8 plus 6 minus 3? 11 newtons per coulomb. Okay. Now those are the components of the resultant. So let's redraw that. I'm going to start here. I can just randomly pick a spot on my paper where I have some space. Goes negative 2 and up 11. Now here's the thing. That is not tip to tail. And if there's one mistake that students make, it's drawing in the resultant before they go tip to tail. You guys wouldn't do that though. No. Now I'm sure your notes are looking nicer than mine right now. But my resultant, if I start at the beginning and go to the end, I'm going to call that E. Okay, so let's find that. To find the magnitude, did you guys turn the volume down? Because you can just do this on your own. That's okay. To find the magnitude, I'm going to do E squared equals 11 squared plus negative 2 squared. That's 121 plus 4. Or 125, I hope. Take the square root. I have 11.2. Keep it at the V sig figs, we'll all be happy. Now, to find the angle, ready? I am going to use a reference angle here of theta. And when I do that, let's see what happens. To find the reference angle, not the angle, the reference angle, I can do opposite over adjacent. So I can say the tangent of theta equals 11 over 2. Now, because I'm finding the reference angle, I leave the sign out. That's just a triangle, 11 and 2. 11 and 2. So I take the inverse tangent. Essentially, I ask my calculator, what angle would have a ratio of 11 over 2 for those two sides? And my calculator says, I'm going to round 79.7. I'm going to call it 80 degrees. Okay. Now, is that 80 degrees? Which way is 80 degrees? Point. No, you all got that wrong. Coordinate plane. Quick review. What's this number here? 0? What's up at the top? 90? 180? 270? 360. We're going to be working in degrees. So 80 would be in the first quadrant. But our answer is not in the first quadrant. Our answer is in the second quadrant. 80 degrees. So what is the actual angle? What is the actual heading? I think what I would need to do to find the actual angle, you may want to call it the heading. I would have to do 180 minus 80 or at 100 degrees. Okay. Did that go longer than you expected? No, because you probably looked at the time before we started. Did it go longer than I expected? Heck yeah. But see how quickly it all ties together? If you start off too confident, you'll miss stuff. If this is easy for you, awesome. If it's not, you should probably get up to speed now. School's starting. I finally get to see you guys next Thursday, Friday. I'm psyched to find. No, wait, you guys. I see next. I don't know when I see. Next Thursday. Next Thursday. And then we start synchronous on Friday. Hope you guys are well. Thanks for playing along. I hope your notes look good. See you on Thursday.